My name is Gerhard. Together I'll be presenting with Kyle. This talk is a forcing function. What that means is that this is a dry run for a talk that we'll be giving on June 21st, part of the Equinix demo day. This talk will have exclusive content. We will not be showing all of this in that talk. We just want to see what content works. And we're focusing a bit more on the infrastructure side today. So today we'll be talking about what does it take to run Dagger on Equinix Metal. Equinix Metal provides bare metal machines via an API. They have a CLI, so you can very quickly get bare metal machines and get all lateral power to yourself. This talk also involves Kubernetes. I know that many of you are thinking or are wondering how to run Dagger on Kubernetes. So this talk will cover that. Cool. Here's a quick agenda. Why Equinix Metal? So for me, I spoke about the infrastructure advantage in Ship It Show 29 with Zach Smith. And you can hear it at length. My reasoning about that. I wanted to do this for about 6 months now to see what it would take to run Dagger on bare metal. And this basically puts it all together. Top reasons for me, you can pick your own CPUs, especially those sweet Intel Xeons that they turbo all the way to 5 gigahertz, and that does make a difference if you have a high frequency CPU. You can get those really fast local NVMe disks, a dedicated network that you do not share with anyone, right? Like there's no virtualization, all of it is yours. And you can even pick your own operating system. And this one is especially important for me. Why Dagger? Well, Dagger embodies my ideal CI/CD experience. It runs the same anywhere, especially locally. And for those that try to run a pipeline locally or your GitHub Actions locally, you know how painful that is. I tried and I failed. Also, I get to write my CI/CD pipeline as code. My favorite is Go, but you can use other languages. And this one is, I think the last one is not very appreciated. You have built-in caching. You don't have to think about this. For anyone that's tried to set up caching in CI/CD, you know how painful that is, especially when the caching doesn't work or you have to bust it. Oh my goodness me. Anyways, so there are a couple of prerequisites for this talk. And by the way, everything I'm showing here today, you can reproduce yourself. There's a Dagger CLI, the Metal CLI, to provision the infrastructure, and the Telos CTL. Telos CTL lies down the operating system and it will configure the Kubernetes cluster for us. A couple of extras, you don't really need them, but they just make your life easier. There's a directory env, or dir for short, that will just basically load some environment variables for us nicely. kubectl or kubectl or kubecontrol, however you want to pronounce it. We're still friends. That's just to interact with the Kubernetes cluster, and K9s, which is a CLI, just to give us a nice view into what's running. Cool. So there are 5 steps to deploying all of this to Equinix. The first step, and by the way, there's a prerequisite. I'm having a bunch of variables configured in envarc, and that's where the directory env comes in. Telos CTL gen config. It basically generates the config for my cluster that will be that I will create in the next step. There's an extra thing which basically needs to prepare the config for user data so that when the hosts boot and they use the operating system, we can provide them with user data so they configure everything exactly as we need it. So there's just like those seds. It's a small gotcha, but worth mentioning. So once we have our config for the infrastructure declared, the next step is to create a control plane. And by the way, you should repeat it for as many control planes as you have. Usually they recommend 3. We just went with 1. And once we have a control plane, we just need a worker. So that's it. 2 hosts, 1 worker, 1 control plane. We can see we're setting the size, we're picking the metro. You can have a play with the Metal CLI to see what options are available. 5 minutes later, we get our devices deployed. So I'm going to run this metal device get. You can see that I deployed this a few hours ago. So they're freshly deployed devices. It takes about 5 minutes to get there. So in 5 minutes, you have your infrastructure set up. Once we have the basic infrastructure in place, there's a couple more things that we need to do. First of all, we need to get the config locally, so we can interact with those hosts that we deployed, and we need to bootstrap the cluster. This is just so that it forms. I mean, the machines are ready, but they aren't formed yet. talosctl bootstrap does that. And then once the machines are deployed, we can observe them. So let's try that locally. talosctl, I'll go for a dashboard. And this basically connects to the control plane, to my control plane node. My font is very big. This usually looks better. You can see a log. You can see the various states of like what controller manager, various resources, if they're healthy, and the state of the various services specifically. F2, you get like some very nice process tree, network, CPU. All this is available in the CLI. Cool. And by the way, this was the control plane, but I can also go to the worker node, and I can do that by specifying a node explicitly. Cool. The next one is to finalize the local config. talosctl kube config downloads the config locally, and once I have that, and it's all configured, I can use K9s, which I'm doing here, to just basically get a view into this cluster. I'll go nodes to show me, no, I just want node. And I can see I have one worker and I have one control plane. So we were looking at the control plane before, but worker, it's accessed the same way. As you can imagine, all the workloads go on the worker, everything else stays on the control plane. To get to about here, it takes about 10 minutes, right? So once you know the commands, you have all the commands configured, it takes about 10 minutes to get here, and probably less if you go fast. Okay, so we have this infrastructure set up. We have a Kubernetes cluster, we have a control plane, we have a worker. So the next thing is to deploy Dagger, right? And we have it all captured here. So if I open Dagger, obviously the Dagger namespace, that's very simple. I think this is the most interesting part, which is the daemon set, the Dagger daemon set. We deploy the engine, we declare the image. This is really important. There's a couple of arcs that we can provide. This one's important, especially if you want to connect to it via TCP. OCI max parallelism, by the way, this one should be match the number of CPUs if you can. Otherwise, we'll use everything that's available on the host. That may be too much. We want to make it beefy. 1123, one of my favorites. It needs to run as privileged, and we mount some volumes, and we'll ignore this one for now. There's like a trick there. The important thing is to always mount the same data volume, so that if the pod was to die, terminate, be restarted, whatever, all the data, all the cache will still be there. That is an important part. That's about it, really. It's like 70 lines. It could be less. There's a lot of comments. I think 50 lines. That's all it takes. The services are not important. What is important is that we check that everything works. So I'll use an NC exactly as I had there, just to check that Dagger is listening. I have a worker host. That's where it's running, worker host, and I'll do Dagger engine TCP port. I can see that that is open. By the way, you should not do this. Again, this is a forcing function. We're rehearsing this talk. This should be secured via WireGuard or something else. We're just doing it for demo purposes. It shows that that's how easy it is to connect to it. But by the way, if anyone can connect to that port, is the equivalent of leaving your Docker running with a TCP port, and anyone can connect to that. So that would not be great. I think the other even more important thing is to check that our CLI, our local CLI, can create a session to the engine. So this basically proves that a local CLI can connect to the server, the Dagger engine, running on this Kubernetes cluster. Cool. And that's where I stop for now. And I have a question for Kyle. What pipeline shall we run now that everything is set up?
Yeah, let's check it out. So we're going to see this. So yeah, what pipeline should we run against this Equinix thing? So that's always a tricky one for demo purposes, right? To figure out, the most effective pipeline. And what we landed on was actually to create a pipeline for Go Releaser. And the reason that we landed on that is because it's a popular open source project for all the Gophers out there, and It has this build pipeline that we found that usually takes about 10 minutes to run. And so that's a good candidate for maybe finding a performance boost for running this on Equinix. So of course, my first step was to take this, if we find our VS Code here. So here's the build YAML for this particular workflow. And as far as YAML goes, it's pretty good. It's only 70 lines, and we've got all our actions locked to the particular checksums and all this stuff. But the problem with this workflow, right, is that we can't run this outside of GitHub Actions. So if you want to run this when you're testing your workflow locally or making some changes on your own end, it's really difficult to replicate this whole environment, right? Because we've got a lot of tools getting set up. We install Task, we install BuildX, Kimu, Snapcraft, UPX, Cosine, Sift, Crew, TPAR, like so many things, right? So in order to properly run tests on your machine, you either need to have all these tools set up or you can run them in Dagger. So I spent some time to rebuild this exact workflow in Dagger. And we can look at this now. Let's move this to the side. And that's not, well, okay. We can see it a little bit. So this is our pipeline now. So I tried to structure it so that it's really easy to look back and forth between this build YAML and this Dagger pipeline and kind of see how they map to each other, right? So I tried to keep those same kind of action steps of how we're installing these tools. And so this is our pipeline, right? We set up Go, Cosine, Sift, Crew, and all these things, like I said. We do Go mod tidy, Go build, and our Go test, which is the main one that we want to get out of this pipeline. And again, we're cloning Go releaser. And in this case, the last tag is the one that I targeted here. And so if we look at, and again, before we jump into a run, if you want to see like what these actions look like, the set of Go one, for example, if I just pop into that. So it's just this function that takes in a container and gives back a container. And we're installing Go through, kind of the recommended path of downloading that tarball and pretend that somewhere in here we're checking the checksum of that tarball and then putting that in our path. And then same for these other actions, right? So all these actions doing the same thing as in the GitHub action that we're copying here, but within Dagger. So let's actually run this. So we talked about we want to run this on Equinix, and Gerhard mentioned those experimental environment variables. So in this case, I've trimmed off the end here, but we can see in my environment, I have this experimental Dagger runner host, and this is pointing to that Equinix host that we just saw running a minute ago. And so now if I do a Dagger run, Go run, and this is running that pipeline that we were just looking at in code, we're going to get some streaming output here, and we're going to see we've got our Ubuntu Jammy base, which is where all our stuff is happening. And so this is all cached. Great. So we took 11 seconds to rerun this cache workflow, and we can see all those steps we did, installing all of our dependencies for that pipeline and doing all these things. And so you can also see, I set up proper caches for Go mods and Go cache and so on. So real quick, let's go ahead and maybe run another commit. So if I go to the commits, and we've got some failing ones here, but let's grab the last successful one so we can see some green. And if I go to VS Code and just, let's say, build this commit instead, and we'll do this live. So now our base for the runner is the same. All the tools that we're using have not changed, but we're going to need to redo, so we can see that all these cache steps, right? All the dependencies have not changed, so we can skip doing all of that, and we're just going to be, in this case, we might have changed the versions for some of our tools, so we're going to reinstall those, but we're just going to be doing the important part, which is our Go build and Go test. We don't have to reinstall everything every run, and now we're on Go test, and the goal here as that's running is to, let's look at this. So our pipeline here in GitHub was 9 minutes. So our goal is to beat 9 minutes. And spoiler alert, we're not going to sit here for 9 minutes and watch it run because it's going to be way faster than that. And it'll be just a second here. So
as we're waiting,
yeah.
Kyle, we have Daniel was asking
Oh wow, questions.
if this is a public repo, and I think you all mentioned at the beginning.
Not just yet.
Yeah, so we'll have, oh no, I made this tinted. That was not on purpose. So yeah, not just yet. We'll be able to, I think in one of the slides at the end, we'll mention how to check out this code.
And then another question while we're waiting is this running in a pod in Kubernetes?
Yes.
It is, yeah, exactly. So we looked at, on Equinix, we have that Kubernetes pod with the Dagger engine. And again, we're connecting to that engine from my local machine here, just with this environment variable. If I were to unset that and run again, then we'd be running, on my laptop here, and we won't actually sit and watch that run. But that's kind of the key here, is that if we want to run on this other host with this other engine, then we're setting that. And I can pass it back to Gerhard for the remaining slides.
All right. So we're running it there. So it's a work in progress. We want to see what would it look like to run the same pipeline in GitHub Actions connected to the same Dagger engine. So that's coming. This is the end. So what comes next? We'll be finishing next week the talk, Dagger on Equinix Metal. In 2 weeks, I really want to try this out in Dagger maybe, just to see what advantage we would see for our own pipeline if we did this. So that's a maybe, because there's like a couple of things happening in the background, but it will definitely be running on my fork of Dagger. And by the way, I was using another Kubernetes cluster, just like to compare some infrastructure, just like to see what CPUs make a difference, the NVMEs, things like that. So that's kind of already happening in my fork, but it's not using the Equinix Metal infrastructure yet. June 21st, anyone that wants to see the full talk, and by the way, some content will be different, a bit more polished, there's a YouTube live stream that you can join. Thank you for today.
Thank you. Before we move on to the next one, there were some additional questions. I think it gets answered in chat, but just for the recording. Is this using a D&D service from Andy?
Yes. Yeah, so it's the Go releaser tests themselves require Docker to go through and test its own functionality for running Docker builds and running different containers and things. So to accommodate that, I'm using a D&D service as a service binding to let it actually run those Docker commands rather than trying to squeeze that into the same pipeline.